Today we'll be going over the quotient law of exponents. We will simplify monomials, also known as terms, using the division law of exponents. When we divide terms, monomials, with like bases, you divide the coefficients as normal and subtract the exponents of like bases. Some things to remember from our last video is that our coefficient is any value that is multiplied to our base variable, in this case would be x. A base is a number that is multiplied by an exponent. And our exponent is the power, or how many times, in which we will multiply a value to itself. So in this case, the same example from last time, the x to the power of 4 does not affect the 3, so it's still 3. And this x to the power of 4 says that we are multiplying x a total of 4 times by itself. So that's how exponents affect everything. Now the rule that we're saying is anytime that we are dividing a base with the like bases, in this case a, we are going to subtract the divider from what is being divided. In this case, n is dividing m, so we are subtracting n from our m value. An example of what that looks like. We have x to the power of 8 divided by x to the power of 3. We can simplify this to say our x base is going to be 8 minus 3. Now we can simplify this. We can do 8 minus 3, which would give us x to the power of 5. Now the way this works, if I were to write all this out, what I'm saying is that if I had a fraction bar and wrote out all the times that I'd be multiplying x by itself, 3, 4, 5, 6, 7, and 8. We would be multiplying x by itself 8 times, and then we're dividing it by x multiplied by itself 3 times. So as you can see, this is a lot simpler than writing this all out, but for explanation purposes, I'm going to go a little bit more. When we divide by a like term, or a like value, it cancels out. So in this case, we cancel out 3 pairs. This will leave us with 5 times that x is multiplying by itself, which is what we got as the answer. So that's how the quotient rule works if it is completely written out so that you have a visual representation. But it's a whole lot easier to write it this way, showing that I'm going to be subtracting 3 from the 8 value. When we have coefficients, it still follows the same rule. We can divide 16 by 4. This would give us 4. Y to the power of 10 divided by y to the power of 8. Those are like bases, so we subtract 8 from 10. Oops. Forgot to write my base. So we would have y to the power of 2. And then our x variable, our x base, would be 4 minus 2, which would give me 2 as well. So my answer for problem number 2 would be 4 x squared y squared. Now for the order, we put the coefficient up front, and then we try to keep our variables in alphabetical order for simplicity, for later on. It can work where it's switched and keeps in the same order. Obviously, it comes from our problem, but it's more manageable when it's out like this when we're dealing with more parts to a problem. When we divide a coefficient, in this case, it will simplify to be 1 over 3. 5 over 15 is simplified to be 1 over 3. When we subtract, it is actually moving up to the top side. We're keeping the values to the top. So we're doing 9 minus 3 for our x value, or x exponent, which would give us x to the power of 6. And y base would be 5 minus 3, which would give me the y variable to the power of 2. 5 minus 3 gives me 2. Now in this case, 1 on the top side with our variable is just a coefficient. I don't necessarily need it there. I can have it as x to the power of 6, y squared, all divided by 3, and that would be a simplified answer. Number 4, if we look at it, 30 divided by 6, that will give us a whole number. That will give us 5. R cubed divided by r to the power of 5 will be r to a negative 2. So this is as if it was moved up to the top of our fraction where 5 was. And last, our variable p. We can write out our p. We have 7 minus 4, which would give us p to the power of 3. Now to follow the order that you've learned so far, we want to switch these around. So it's actually 5p cubed r to the negative 2. Now, for what we have learned so far in our lessons, this will be our final answer. But in a later lesson in this unit, you'll see how we can simplify this even further so we're not dealing with a negative exponent value.